In this video, we're going to go through a 15-mark exam question actually on mechanics. There's quite a lot of information here. There's resultant forces, there's using moments, using F equals ma, conservation of energy even. So let's break it all down. This isn't all the question, by the way. There's more here and here as well. So let's break it down. It tells you there's a reverse bungee. It tells you there's two identical elastic ropes. Okay, so whenever there's a rope or any sort of tow bar connecting two objects, there's always tension acting, and it always acts up the rope. So let's label that straight off the bat. It's fixed to passengers, so it's held in place by a clamp. There's a point P, which is the vertical point that the string reaches. There's a point Q, which is on level with the cage. It tells you before release the tension in each rope is 3.7 times 10 to the 4 newtons. So I'm just going to write that out. Sorry if that's a little bit small, by the way. And that's the same tension across both because they're both identical ropes. It also tells you that the mass of the loaded cage is 1.2 times 10 to the 3. Sorry if you guys can't see that, kg. And the mass of the ropes is negligible, so we don't have to take into account the mass of the ropes in our calculation. Show that the downward force exerted by the clamp on the loaded cage is that much. So first of all, let's establish what force that is. By the clamp on the loaded cage. So if we draw out this system, we know there's weight acting vertically downwards because it's given us the mass of the loaded cage, and we know weight is equal to mg. So it's the mass of the loaded cage multiplied by g. So let's find that actually first. 1.2 multiplied by 10 to the 3 multiplied by acceleration due to gravity, which is 9.81. I'm just going to type that into my calculator quickly. Times 10 to the 3 times 9.81. And that's equal to 11,772 newtons. So 11772 newtons. Moving on. We also have vertical components of the tensions, not the tensions themselves because they're at an angle. To find that vertical component, what we can do is form our own right angle triangle. Using the fact that these lines are parallel lines, you can use the alternate angle rule or the Z angle rule to say that this angle here is also 20 newtons. What's the component of the tension going to be in this vertical direction then? Well, if we draw out a right angle triangle here, actually I'm going to change the thickness of the pen. I feel like it's a little bit too thin. Yeah, so we have that this hypotenuse represents the tension. We have that this angle here is 20 degrees, and we want to find the vertical component. Let's call it y. So because this is a right angle triangle, we're using the hypotenuse and we're using the adjacent. We can say cos of the angle 20 is equal to the adjacent, which is y, divided by the hypotenuse, which is tension. Multiply both sides by tension and we get that the vertical component is t cos 20. Now that not only acts due to this tension, but also due to this one. So that means that there's two of these vertical components of the tensions. So because there's two t cos 20s acting up the rope, we say that in total there's 2t cos 20 degrees of vertical force acting up on the rope. Now it says show the downward force exerted by the clamp is this much. The downward force exerted by the clamp is the resultant force between this force here and this force here. So let's first find out what 2t cos 20 is, because we know what tension is. I labeled it here and it was given in the question. So we do 2 times 3.7 times 10 to the power of 4 times cos 20. That's 2t cos 20. I'm just going to very quickly do that on my calculator. When you're dealing with sine, cos and tan, remember to put your calculator in degrees mode, otherwise it just leads to an unnecessary error, even if you're doing the question correct. And that gives you 69537 newtons. And then the resultant force is just the larger one, take away the smaller one. So the total, the larger one here, 69537, take away 11772, and then that should round to 6 times 10 to the 4. I'm just going to quickly double check that it does. So when you take those away, you get 57765, which in standard form is just 5.8 multiplied by 10 to the power of 4, which when you round it to one significant figure is just 6 times 10 to the power of 4 newtons. Perfect, that's everything for that question. It then tells you to calculate the initial acceleration of the loaded cage when the clamp is released. Well, straight off the bat, we know that F equals ma, but F always stands for resultant force, not just a singular force. We found that resultant force in the previous question, so we can make that resultant force 5.8 times 10 to the 4, equal to the mass of the loaded cage, which is 1.2 times 10 to the 3, multiplied by the acceleration that the loaded cage is offset with. Dividing both sides by this value here, we get the acceleration. It's 5.8 times 10 to the power of 4, all divided by 1.2 times 10 to the power of 3. So I'm just going to very quickly do that on my calculator. So it's the value that we mentioned divided by 1.2 times 10 to the power of 3. And that's equal to 48.1 meters per second squared. Might sound a bit quick, but that's to be expected because, yeah, we'd expect the clamp to sort of spring forward pretty quickly. Moving on to the next part of the question, it says the unstretched length of each of these ropes is 24 meters. The rope obeys Hooke's law, where force is equal to a spring constant multiplied by extension, or force is directly proportional to extension. The vertical distance between points P and Q is 35 meters. Yes, it's already said that before. And it wants you to show the total elastic potential energy stored in both ropes. So you have to find for one of the ropes and multiply by 2 because it's the same across both ropes. Before the loaded cage releases about 5 times 10 to the 5 joules. Okay, so we want the total elastic potential energy in this diagram here, given that the unstretched length is 24. So you guys can spend a minute doing this if you like, but yeah, I'll go through it. Let's first think off the bat. What equations do we know for elastic potential energy? There's two that come to mind straight off the bat, a half Fx, a half times force times extension. And because we know the force acting on the ropes is tension, we just need to find extension somehow. How do we find that extension? Well, if we find the length of this string PQ when this force is acting on it by creating our own right angle triangle, since we know the vertical height is 35 meters and we know this angle here is 20 degrees, we can focus on finding this this length PQ, and then subtracting this stretched length from the unstretched length, we get the extension. So let's do that. So this here, we don't know it. Let's call it, I don't want to use the same letter again, so let's call it A. Okay, wait, no, that matches acceleration. Let's just call it a question mark. Okay, so since we're using SOHCAHTOA, it's a right angle triangle, we're interested in the adjacent and the, the hypotenuse is always the right angle, opposite to the right angle, and the adjacent. So that's the cos. So we can say cos of 20 is equal to the adjacent, which is 35, divided by the hypotenuse that we're trying to find. And we can replace the positions of the hypotenuse and cos 20 to say that the hypotenuse is 35 over cos 20. Put that into a calculator. 35 over cos 20 is all, oh yeah, you remember to close your sign at the end of the sine, cos, or time, so you get mass errors. 37.2 meters. So that's the stretched length, and if we subtract from that the unstretched length, so 37.2 take away 24, that's equal to 13.2 meters, and so that's your extension. Now that we know the extension is 13.2 meters, we know the force on the wire is, what was it? How do we just calculate? Oh, sorry, it was given to us 3.7 times 10 to the 4. We can now combine these to find the elastic potential energy that's stored, because we know the elastic potential energy is a half times the force times the extension multiplied by 13.2, and all of that is equal to, so let's do that quickly, half times F times extension is equal to 244,200. Now, do you remember that that's the elastic potential energy stored in one of the wires, but we want to find it stored in both ropes. So then we multiply that answer that we just got by 2. And that's what gets you to 488,400, which is 4.9 times 10 to the power of 5, which approximately rounds to 5 times 10 to the power of 5 to one significant figure. So we can do that, this squiggly line, which shows that it's approximately 5 times 10 to the power of 5 joules. Perfect. And now says the designers of the ride claim that the loaded cage will reach a height of 50 meters above Q. Decide whether this claim is justified. Well, let's think about it. When it's released, it has all this elastic potential energy, but that elastic potential energy turns into something else when it's released because it gains height. So it turns into gravitational potential energy. Let's find the maximum height that it can reach. In that case, what we're assuming is that all of the elastic potential energy that's lost as it is released due to no tension in the wire, all of it turns into gravitational potential energy that's gained. And what do we know gravitational potential energy is equal to? It's equal to mgh. So we can make all of mgh equal to the total energy that we found beforehand. And I'd always recommend you use the rounded value that you found rather than, the non-rounded value that you found. It's going to lead to less errors later on in the working out. So because we know the mass and we know the value of g, we can just rearrange for h, and we can find the maximum height that's reached whenever this much energy is used for gravitational potential energy. So the mass of the system is 1.2 times 10 to the power of 3. And you're multiplying onto that g, which is acceleration due to gravity, 9.81. That should be, well, let's check actually. Sorry, I did this question quite a while ago, so I don't remember the answers. 3 times 9.81. Okay, so it's equal to 41.5 meters. That means that the maximum height that I can reach is 41.5 meters. So discussing that claim, it's not justified because it won't reach 50 meters above point Q. The maximum that I can reach is 41.5 meters above Q. But even then, that you might have noticed that's unrealistic because that's assuming all of the potential energy turns into gravitational potential energy. But in reality, some of it will turn into kinetic energy because, it has to move in order to move upwards. So in reality, this height will be lower. But this just gives you an idea. The designers also claim that the loaded cage reaches a maximum speed of at least 90 kilometers per hour. Calculate the kinetic energy when it travels at 90 kilometers per hour. Okay, so kinetic energy, the equation for that is a half mv squared. We know the mass of the system, we just use that same mass again, 1.2 times 10 to the power of 3. But do we know the velocity? Sorry, I'm just going to quickly write this out. 1.2 times 10 to the 3. Well, we don't know the velocity directly because it's given in kilometers per hour. We have to convert it into meters per second. So first of all, to go from kilometers to meters, you multiply it by 1,000. And to go from per hour to per second, well, in 1 hour, there's 3,600 seconds. Multiplying all of that together, we actually get 25 meters per second, if I'm not mistaken. I'm just going to double check that. If I'm right about this, you have to like the video. Yeah, it's 25. I'm not some math genius, I just remember doing this question before. So half times mass times that velocity squared. And then all of that, I don't remember this answer, so I'm just going to quickly do it. Answer squared times 0.5 times 1.2 times 10 to the power of 3. 375,000. When you get a large number like this, I'd always recommend you write it to not only to two significant figures, so 3.8, but also in standard form, so times 1, 2, 3, 4, 5 to the power of 5. And that's everything for this question. Quite a long-winded question. Hopefully you guys understood everything though. If you guys do have any questions, please let me know in the comments. Otherwise, thanks for watching. Be sure to subscribe and like the video. I'd appreciate it a lot.